At the end of 2020, the Malaysian population now is about 34 million. From 1970, the Malaysian population is exponentially grow or not? Hi, I'm Kadri. In this lesson, we are going to learn about exponential functions. At the end of this lesson, you will be able to determine the growth rate of the standard exponential function at any point using a graph slope. Alright, let's go. Alright, so this is a exponential function where it has a base a and a power by x. If we draw this function on a graph where it has the same scale, right? So x scale and y scale, they have the same scale. So this is a y 4 power by x, exponential power by x, 2 power by x, all right? And y equal to 1 power by x. Right. If you notice all of them, they have a different slope, okay? Different slope. And this base will determine the slope, and they will have different curve. Okay. All of this graph meet at this point. This is 0, 1 point. Okay, that means all of these curve meet at this point. For a equal to e, where e is exponent number, we can write y equal to exponential power by x, or it is called standard exponential function, and can be written as exponential xp or xp in the argument of x. Alright, so this is a special exponential function, and it can be a standard of all of these exponential functions. Okay, why standard exponential function where e power by x is so special? Alright, so in this graph, y and x are having the same scale. Okay, and then this is the graph of y exponential x. Right, if I stretch this this x scale, so we stretch, expand. Okay, so while maintaining the graph, the curve of exponential, it will meet 4 power by x. Alright, and if we contract, we squeeze y-axis, okay, this exponential power by x will meet here, for example 1.25. so in this base, this means that all of these exponential graph can be represented by exponential x. That means this standard base can represent all if we have an appropriate factor. That means if we squeeze or stretch the x-axis, all of them can be represented by exponential x multiplied by appropriate factor. So that's why the exponential x is special. So it can represent all of the exponential functions. So let us estimate the value of exponential, the e. From the previous graph of all the of the exponential functions, the value of e falls between 2 and 3. Okay, it is between 2 and 3. So what is the exact value of the exponential e? Alright, so e is the number such that the graph of y power by exponential x cuts the y-axis at 45 degree. So if we have this graph where it has a same scale, x and y. And then let's have a 45 degree. This is 1 and this is 1.5. Okay, this is my 1.5. So let us have a one slope. Okay. Okay. So the graph at this point, so at this particular area point, the graph of y equal to exponential x cuts. So cuts. So if we can have slope here, it cuts at 45 degrees. So that e will have a number so that it cuts at 45 degrees. So what is that number actually, right? Okay, from this graph, so let's define several points. So we have a point of D where it is from H. So H is any number from the origin, and it is y. It is a y here because it cuts at this axis at 1, and then any points on the graph where it is located at H. So this is x-axis and it is exponential exponential h, because exponential x equal to h. So this is the coordinate of C. Okay, and then we have a one point B where it is actually extended from this 45 degree slope. Alright, so BD divide by AD. So BD, where is BD? BD here divide by AD. Okay, BD divide by AD is actually tangent, right? And tangent 45 is equal to 1. So that we know it. Alright, so as H, so if we as H is closer to 0. Okay, as H is closer to 0. Okay, and so that C, so when this is close to 0, so C will also close, right? C will close to this. Okay, it will close down. Okay, so it will become very close. Okay, that means CD. All right, CD divide by BD, because this is become smaller as we go to the left, so it will be equal to 1, because 45 degrees means this will be close to 1, because this divided by this is equal to 1. Alright, so in that case, alright, now we know that this CD is from here to here. Okay, this is equal to, because this is e power by h, and this is 1, right? So the value of this CD is equal to EH. So EH, because EH is calculated from 0. Okay, so below, this is 0 below. Alright, there is 0. Okay, so EH divide by EH minus 1. So EH minus 1, so we get the value of CD. Okay, and AD, this is equal to H. So that, right, so that when we multiply BD times CD, okay, when we multiply these two terms, right, so this is equal to 1, right? This is from here. Okay, CD is from above here. Okay, that means we can cut BD, so we get CD over AD. So CD is from above. The previously we said that EH, so EH minus 1. So EH minus 1, okay, divide by H, because AD is equal to H. So this is equal, it is not equal, actually it is approximate to 1. Okay, this is approximate to 1, because this is 1, this is approximately equal to 1. So 1 multiplied by something approximate to 1 is equal to approximate to 1. Alright, so to estimate the value of E, what we can do is that we rearrange back this. So H, we bring it to the right. Okay, we bring to the right, so that we have E power by H is minus 1 is appropriate to H. And then EH, so we just rearrange them back. So H we bring to the right, we have a 1 over H power by H. Alright, then then we try to have a numerical calculation. So because h is very small, so if h equal to 0 0.1, so we have this term equal to 2.5937. Alright. If we get it smaller, 0 0.01, we get this. So as we got it smaller, we will have exponential equal to 2.7182818. Okay. So because when h is small enough, then we have this triangle, so that it will have fulfill the definition, that is E is the number of such that graph blah 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 at 45 degrees. So we get exponential is equal to 2.7 blah blah blah. Okay, so because it is an ended number. All right, then we can from previous slide we can see that the e power by h minus 1 over h is approaching 1. Okay, this is approaching 1 here. Okay, approaching 1 as h is closer to 0. Okay, this is what we can have a property of the exponential function. So since h cannot be 0, it can be close to 0, but it cannot be 0, because if it is 0, then we have this meaningless calculation. Alright, so from the definition of exponential, the rate of increase or growth rate of function exponential x at x equal to 0 is 1. That means the increment of the function at this is equal to 1. Okay, this is equal to 1. Okay, and then that is for the point here, but what about at another point? For example, here, what is the grow rate? How much it grow at certain point? So to get that information, the grow rate is equal to the slope at that point. Okay, so at this point, let's concentrate at this point. To get the slope of this point is equal to we take 2 points. Okay, we take two. We can draw a slope. Okay, we draw a slope here. Then we can define a triangle here. So the slope is this divided by this. Okay, so that's why we get this expression x power by h, because this is x exponential x power by x plus h. Okay, divide minus x minus power by x, so we get here. And then this another point, because this b point is here, so we divide by this, so we get this length. So we simplify, we'll get this. Alright, so from here we can expand this exponential this power, exponential power. Okay, and then we can separate it as x exponential power by x and exponential power by h. Alright, and then let us factorize. Okay, so let's factorize ex over there. Oh, I'm sorry, I have made some mistakes. So this is actually x. Okay, this is x, this is x, so that this is x, and then we can factorize ex outside. Okay, then we get here. So as h equal to 0, so this is the property that we use for this. So we use is approaching 1. So this is approaching 1. So when it is approaching 1, that means ex will close to ex as this h becomes small. Okay, so what does it mean is that the grow rate at this point is equal to the exponential function itself. Alright, so the grow rate of this y equal to negative power x at any point x. Okay, that's mean the slope of y y is also equal to itself. Alright, so this is the important thing that we can get from here. So when we go into this teaser, the thing that we have in the first slide. Alright, so the when this is for formulation population. So they is it exponentially grow? So we can check its slope because this is the grow rate. Okay, this is the grow rate. You can see that this is almost exponential. This is almost exponential. This is almost exponential. That means from the trend, only a part of it exponentially grow. So this is the exponentially grow area. This is exponentially grow area because of the slope is also exponentially grow. Okay. How about the other? The other is not exponentially grow, so we need another function to describe another interval from here. For example, here, this is almost low grow, even though it's positive, but it is not exponential grow. Okay, so this is for Malaysia, this is for Indonesia, okay, and this is for Germany. So it is interesting to see that the German's population is not increasing, and the growth is also jumping up and down. So there must be something happen here. All right. So from this, we can use another method to describe the population profile for each country. All right. So we'll go to the next lesson about the logarithmic graph. Thank you.